much further away than Mars, there is another unique world that might harbor life. Our next destination in the search for life is one of the most fascinating Jovian moons, Europa. Europa is one of the 4 largest moons of Jupiter. It's slightly smaller than our moon, and its icy surface is minus 160 degrees Celsius. Virtually everything we know about Europa is thanks to NASA's unmanned space probe Galileo, which passed by Europa 12 times. These were the first images it captured. It is covered by a smooth layer of water ice. In fact, it has the smoothest surface of any known solid object in the solar system.
The surface of Europa is unique in the solar system. It has very few craters, which tells us that the surface is being reprocessed frequently.
Some parts of its surface show blocks of ice that are separated, but seem to fit together like a puzzle. These icebergs could have been shifted by slushy or liquid water beneath.
These cracks probably may extend all the way down to the ocean, to the ocean, or at some point, so you could get some percolation of water.
This peculiar landscape is very similar to sea ice on Earth.
Galileo is able to detect that. All of those things together add up to our picture of how we now know that Europa has a liquid ocean under its surface.
In 1996, the Galileo spacecraft detected a magnetic field on the planet's surface, indicating that there must be some electrical conduction likely to derive from a salty ocean that could be 60 miles deep.
The studies and observations, measurements that have been made in the past decades seems to be converging pretty clearly with the presence of an ocean under the surface of the ice.
So there we have the first key ingredient for life, liquid water. How can water remain liquid at temperatures of minus 160 degrees Celsius? Some sort of mysterious internal heat must be melting the icy crust. Jupiter is the key. Tidal heating from friction due to Europa's eccentric orbit around Jupiter has been proposed.
The ice on the surface of Europa is being cracked. It's not completely sealed. You can see, because of gravitational pull and pull, there is this tug of war as Europa is moving around Jupiter. You can imagine that all this friction is creating lots of energy, lots of heat, and then we have good reasons to think that there are hydrothermal system, which means that you have, water being heated by this process.
Volcanoes deep down may harbor hydrothermal vents that provide an energy source to heat and maintain liquid water. So we have 2 of the 3 conditions for life: a liquid, in this case liquid water, and a source of energy, that interior heat. We would just need some organic compound, and the chances of life arising would skyrocket. The Galileo spacecraft observed that Europa's ice contains carbon dioxide. When this carbon dioxide is strongly impacted by Jupiter's radiation, it can produce simple organic molecules such as formaldehyde that are steps towards life. The aforementioned tides on Europa could also mix life-supporting substances together in the ocean, but nothing has been proven yet. On 2013, NASA reported a surprising discovery on the icy crust of Europa. Some clay-like materials, specifically phyllosilicates, were detected.
Phyllosilicate just means phyllo, like layered silicate, and these are a fancy name for clays. And clays are a kind of mineral that forms in a lot of water. And on Earth, there are some theories that these clays were some of the original minerals that were present when life was evolving.
According to some hypotheses, the presence of these organic associated minerals may have been the result of a collision with an asteroid or comet. With liquid water, an energy source and the necessary chemical building blocks, perhaps delivered by comets or asteroids, Europa opens up the possibility that life could exist in places never imagined. "12,000 feet beneath the Arctic ice sheets, in complete darkness, there are hydrothermal vents that spew out superheated water with lots of toxic chemicals. Scientists think vents like this could also exist on Europa's ocean floors.
We think that the potentially source of energy for an ocean Europa will be the volcanic activity.
We have recently discovered that clustered around the vents, there are extremophile microorganisms that cover miles of the Arctic seafloor. The discovery of life there really raises the possibility of life on Europa.
Probably Europa might be the best candidate for us to find extant life.
The challenge now is to prove that life has been able to thrive in such a bizarre environment. NASA and ESA have planned 2 different missions to Europa that will investigate its habitability in the next few years.
In 2015, NASA approved a new mission to go to Europa and investigate its environment, and particularly to look for habitability.
NASA's Europa Multiple Flyby mission is a spacecraft that will be launched in the 2020s. The spacecraft will be a highly capable, radiation-tolerant probe that will perform repeated close flybys of the icy moon.
We'll also be looking under the surface to learn more about the structure of the ice shell and the structure of the ocean underneath the shell, using radar and magnetic field detectors and other instruments.
The ESA is developing in parallel its own mission, the Jupiter Icy Moon Explorer, the so-called JUICE mission, that is planned for launch in 2022 and arrival at Jupiter in 2030. This spacecraft will spend at least 3 years making detailed observations, not just of Europa, but also of the giant gaseous planet Jupiter and 2 of its largest moons, Ganymede and Callisto. We will have to wait till the next decade to confirm whether or not there is life on Europa. Europa isn't the only intriguing place this far out in the solar system. Could similar conditions exist on other moons orbiting other planets, even further away from the Sun? Orbiting Saturn, there is a small, mysterious moon that is totally different from the rest of its more than 60 moons. This tiny icy moon, only 300 miles across, is Enceladus. In the last few years, this tiny moon has become the main goal for exobiology, as it has revealed some extraordinary conditions for harboring life.
Most of what we know about Enceladus is thanks to a mission called Cassini. It's a mission that it's been going on for many years. It's an orbiter that has been studying the entire Saturn system and its different moons, but it's been paying close attention to Enceladus.
The Cassini mission offered us a close-up of this remote world for the first time ever. These were the first images it took. The surface is white and glittering, and it is carved with fissures, crests, and cracks. At the South Pole, Cassini made a surprising discovery. It photographed some strange, large cracks, seen here in blue. 4 parallel fissures, scientists named the tiger stripes. They are 75 miles long and hundreds of feet deep. They are similar to fault lines on Earth. After several flybys, Cassini's thermal radar revealed something unexpected. The tiger stripes should be colder than the rest of the moon, as they were in the South Pole. However, they were radiating heat. The fissures were at minus 80 degrees Celsius, which was more than 120 degrees Celsius warmer than the rest of the moon.
It's definitely a place where we see evidence that something profound is happening in terms of potential for habitable environment.
But the most shocking finding was still to come. When Cassini was reoriented, it captured a shocking image. Vast jets of ice were erupting into space.
The camera was able to image plumes of water vapor and ice crystals coming off the South Pole of Enceladus.
These actual images showed the plumes were ejecting ice particles hundreds of miles out from the tiger stripes.
Those materials are being ejected through fractures on the surface of the moon, which seem to be connecting the surface with the interior.
However, how this small moon can generate so much heat as to be able to maintain such geothermal activity? Scientists believe that Enceladus might have an internal energy source, like Europa. When it orbits the massive Saturn, friction from gravitational process causes it to heat up, melting ice in the moon's interior in the same way as on Europa. These jets were giant geysers of water that erupted from its icy surface, much like those in geological hotspots on Earth.
Cassini actually has a detector that can fly through the plume, pick up some of the particles and analyze them chemically. And when that detector did its work, it found that some of the particles are salty. And the only way to get salt incorporated into a particle is to have it evaporating directly off of liquid. So that was yet another hint that Enceladus has liquid under the surface from which these plumes are emanating.
But could it prove that under the icy crust of Enceladus existed a subsurface ocean, like on Europa?
We needed even more evidence. The next piece of evidence was from Cassini flying past Enceladus and just carefully analyzing its trajectory as it flew past Enceladus to directly measure how Enceladus's gravity was pulling on the spacecraft. And when that analysis was done, it found a density anomaly under the entire South Pole, indicating that you have a regional sea of water from which these plumes are emanating.
These jets might be connected to active hydrothermal vents at a subsurface water ocean floor, where the moon's ocean meets the underlying rock, a prime potential habitat for life. But there still wasn't anything that could prove life existed underneath that icy crust. The probe spectrometers detected something really exciting. They found in the jets the basic chemical building blocks of life.
So Enceladus is fascinating because, as far as we can tell, it contains the 3 basic ingredients for life: liquid water, nutrients, and organics.
But does this strange and alien world actually support life? The geysers could provide easy access for sampling the moon's subsurface ocean. And if there's microbial life in it, ice particles from the sea could contain the evidence astrobiologists need to identify them. There are 2 exploration missions proposed by NASA to Enceladus in the near future that would try to find evidence of life in the tiny icy moon. The first one is the Journey to Enceladus and Titan mission. This is an astrobiology mission concept to assess the habitability potential of Enceladus and Titan, moons of Saturn. The second mission, waiting for approval and financing, is the Life Investigation for Enceladus.
This proposed mission would capture icy particles from Saturn's moon, Enceladus, and return them to Earth, where they could be studied in detail for signs of life, such as biomolecules.
It's relatively simple, technologically speaking, to send an orbiter to Enceladus that can capture those icy particles in the plume and analyze them in situ or bring them back to Earth for detailed analysis in the laboratory.
Unfortunately, none of these missions have been approved yet. So we will still have to wait to unveil whether or not there is life on this tiny, enthralling moon of Saturn.